Hello class, today we're going to talk about section 2.3, solving one-step equations. The first thing we're going to talk about are the properties of equality. The addition property of equality states that if you add the same value to each side of an equation, the sides remain equal or balanced. An example of this would be 6 divided by 2 equals 3, and if we add 5 to both sides of our equation, 6 divided by 2 plus 5 equals 3 plus 5. If we solved both sides of our equation, they would both simplify down to 8. Algebraically, this would look like if A equals B, then A plus C equals B plus C. Please take a moment to pause this video and write down the addition property of equality. The subtraction property of equality states that if you subtract the same value from each side of an equation, the sides remain equal or balanced. An example of this would be 10 divided by 5 equals 2, and 10 divided by 5 minus 4 equals 2 minus 4. If we evaluate the left side of our bottom equation, we get 2 minus 4, which is negative 2. And our right side of the equation, 2 minus 4, is also equal to negative 2. Algebraically, this would look like if A equals B, then A minus C equals B minus C. Please take a moment to pause this video and write down the subtraction property of equality. The multiplication property of equality states that if you multiply both sides of an equation by the same number, the equation remains balanced. An example of this would be if we have 14 divided by 7, we know that's equal to 2. If we multiply both of the sides of our equation by 7, 14 divided by 7 is 2 times 7 equals 14. We evaluate the right side of our equation, 2 times 7, that is also equal to 14. Algebraically, this looks like if A equals B, then A times C equals B times C. Please take a moment to pause this video and write down the multiplication property of equality. The division property of equality states that if you divide both sides of an equation by the same non-zero number, the equation remains balanced. It is essential that you divide by a non-zero number. Remember, you can't divide by 0. Any number divided by 0 is undefined. An example of this would be 5 times 3 equals 15. If we divide both sides of the equation by 3, both sides of the equation are equal to 5. Algebraically, this would look like if A equals B, then A divided by C equals B divided by C. Please take a moment to pause this video and write down the division property of equality. Now that we know our properties of equality, we can talk about how to solve one-step equations. To solve one-step equations, use for inverse operations. Inverse operations are operations that undo each other. The operation addition has an inverse of subtraction. The inverse of subtraction is addition. The inverse of multiplication is division, and the inverse of division is multiplication. Please take a moment to pause this video and write down the process for solving one-step equations and write down the inverse operation of each of the 4 basic operations. Now let's try an example together. We have 2/3 x equals 8. That means we're multiplying x by 2/3. To undo multiplication, we would divide. We're going to divide by our coefficient. So I'm going to divide by 2/3. The golden rule for solving equations is what you do to one side of the equation, you must do to the other. So I need to divide 8 by 2/3 as well. Remember, any number divided by itself is 1, so the 2/3 cancel out, and we're just left with x. Now we need to do 8 divided by 2/3. Remember, any whole number is a fraction over 1, And when we divide by a fraction, we multiply by its reciprocal. The reciprocal of 2/3 is 3/2. Now before I multiply, I can cross-reduce the 8 and the 2. The 8 becomes 4, and the 2 becomes 1. When I multiply, I get 12 over 1, which just is simply 12. Therefore, x is equal to 12. Please take a moment to pause this video and record the example in your notes. Please take a moment to try the next 3 examples on your own. After trying them, resume the video and check your work. In the first example, I'm adding 5 to my variable f, so I need to do the inverse operation of addition, which is subtraction, and subtract 5 from both sides of the equation. When I do this, on the left side, I'm left with just f because the 5's cancel out, and on my right side, -3 minus 5 is -8. Therefore, f equals -8. In the second example, t minus 4 equals 3, I need to do the inverse of subtraction, which is addition. When I add 4 to both sides of the equation, the 4's cancel out on the left side, so I'm left with just t. Then on the right side, I have 3 plus 4, which is 7. Therefore, t equals 7. In my third and final example, I have 6w equals -54. Remember, when we have a coefficient next to a variable, it means we're multiplying. So in this case, my inverse operation is division. I divide both sides of my equation by 6. The 6's cancel out, and I'm left with w on my left side of my equation. -54 divided by 6 is -9. Therefore, I know w is equal to -9. If you want to go back and check your work, you can always plug in the answer that you found for the variable and see if it works. In the first example, if I plug in -8 for f, I have -8 plus 5. Is -8 plus 5 equal to -3? Yes, it is. Therefore, it checks out. I can go through and do this with my other 2 examples as well, and I would find that they also check out. Before you finish your notes, please record the following 5 questions in your notes as well as your answers, and come to class prepared to discuss your answers.